Okay, students, the chapter today is what is ductile cast iron and what is malleable cast iron. It was a topic which was raised from your concert or from your department. So, to discuss about it, let us denote what is cast iron and what is ductile iron. So, ductile iron is a type of cast iron known for its impact and fatigue resistance, elongation and wear resistance. Due to spherical or round graphite structures in the metal, ductile iron is also called ductile cast iron. Actually, ductile cast iron is called ductile iron or spherical graphite cast iron, which you might have known, or nodular cast iron. So you can see the pictures. Yes, both ductile or both gray cast iron and ductile cast iron. This is a microstructure of a gray cast iron where you can see the graphite flakes, and here you can see the nodules of the graphites. So if you look closely with a high power microscope and possibly with 100x magnification or more, not less, at a regular cast iron, that is sorry, that is the gray cast iron, you will see the graphite bits looks like the that that lines, they are called flakes. When you look at the graphite in ductile cast iron or SG cast iron, they look like spheres or nodules. Here you can see the spheres or nodules. So this is why it is so different. And yet it is ductile iron. It has become one of the most popular type of iron casting. Development of ductile iron continued into the 50s, making the process of ductile cast iron better, leading to acceptance of ductile iron. Acceptance proven out by ninefold increase in use during the 1960s as an engineering material. So now let us discuss about how a ductile iron is made. So start with the iron, of course, and then add more carbon than the world would normally be absorbed into the structure. Explaining the iron carbon relationship in another way, it is like adding so much salt in your water that you reach a point that no more salt will dissolve. So we have a law also in iron carbon structures. So the lever rule. This is why the ductile iron is different than steel. Steel only has as much as carbon as the iron can absorb. So silicon, sulfur, manganese and oxygen all do their part in the mix to help carbon to form a spheroidal graphite. So the composition of ductile iron, let us come to the composition. That is, iron is 94%, carbon is 3.2 to 3.6%, silicon is 2.2 to 2.8%, manganese 0.1 to 0.2%, magnesium is 0.03 to 0.04%, phosphorus 0.005 to 0.4%, 0.04%, I'm sorry. Sulfur is 0.005 to 0.02%, and the copper will be less than equal to 0.4%. To improve the strength of ductile iron, additional tin or copper can be added. To improve corrosion resistance, copper, nickel or chromium can replace anywhere from 15 to 13% of the iron. So what are the benefits of ductile iron? So ductile iron castings are very strong compared to the regular cast iron or gray cast iron, which normally we say. The tensile strength of cast iron is 20,000 to 60,000 psi, while the ductile cast iron or SG cast iron starts as 60,000 psi and can go up to 120,000 psi. The yield strength for ductile iron is generally 40,000 to 90,000 psi, but the yield strength of cast iron is so low, it is considered as not measurable, or it is neglected as well. So let us put strength in a different way. We have seen gray cast iron parts break when they hit ground after falling 10 feet. So now it is a practical example. Now with the ductile iron casting, you can hit the part all day long with an 8-pound sledgehammer, and it is not likely to crack. So this is in a very practical way. I have jotted down this much. So what causes the problem for gray cast iron is those graphite flakes which encourage fractures along the flake lines or flakes, while the nodules in ductile iron work at keeping the iron together. Given the exact same scenario of the same part is made to different metals, while the brittle gray iron wants to crack and the ductile iron wants to bend. So this is the different, also in a very practical sense way. Now, ductile iron has what is called excellent wear resistance because of the graphite in the iron. So when we have something rubbing against the the ductile iron wears away much slower than many other metals. And the wear resistance is partly from the graphite structures that can act like a dry lubricant on the iron. So ductile iron also dissipates heat very well and can be machined fairly easy. Though ductile iron is harder to work than regular gray cast iron, ductile cast iron dampens vibration and sound much better than the steel wood, making ductile iron a good match for use of large machines. So this is the usefulness of ductile cast iron, or you can say the application part of ductile cast iron. So ductile iron is great for use when you need strong metal with wear resistance. So the wear resistivity part, as I have also discussed. Yes, and let me take you to the structure, microstructure. So you can see this is gray cast iron. I'm again repeating myself. This is gray cast iron, and this is ductile cast iron or spheroidal graphite cast iron. So due to the flakes present here, the ductile iron is breaking easily, and due to the nodular effects, the gray cast iron which breaks, the ductile cast iron actually remains strong. So let me come to the ductile iron, why it is used for the applications. So the pipe and pipe fittings. So in the US, 50% of the ductile iron is done for pipes and its fittings. So axles, connecting rods, crankshafts, cylinders, disc brake calipers, gears and gearboxes, so housing and manifolds, hydrostatic barrels, idler arms. Now large machine, actually the cast product of the large machines, I have to add it, the cast product of the large machines, the machine tooling, it is also the cast part, and other military uses. So this is some interesting example, that is piano harps. the part that holds the string of the piano, the harps actually, those are made with ductile iron. The spindle supports, those are made with ductile iron. The steering knuckles, these are also made with ductile iron. Suspension system parts, truck axles, this is a huge one. Truck axles, this is also made by ductile iron. Valves, usually the high pressure valves, these are made with ductile iron or SG cast iron. The wheel hubs and the yokes of power transmission, these are some examples of ductile iron or SG cast iron or spheroidal graphite cast iron or nodular cast iron. So you have four names actually. It is ductile iron, it is ductile cast iron, it is spheroidal graphite cast iron, it is nodular cast iron, and you have all seen the what should I say? The microstructure of this one. So what is the difference between ductile iron and cast iron? This is also a very common question which is asked in various interviews and other places. So cast iron refers to the iron parts that are cast and have high carbon content but no normal usage. But in normal usage, the cast iron referred to the grey cast iron or grey iron. The cast parts with weaker iron structures containing the graphite flakes. Ductile iron must specifically have the spheroidal graphite structures in the metal. So cast iron or grey cast iron, these are they refer to normally they have graphite flakes, and the ductile iron, they in the other hand must have the spheroidal graphite nodules. Now regular cast iron can be cast cheaply, machined very easily, and strength can be added through heat treating. So this is for the regular cast iron. And grey cast iron lacks the strength, the durability of cast iron. The ductile iron castings are not much more expensive than the grey cast iron castings. Yet, if there is no need for benefits of ductile iron, you should probably stick with grey iron castings. So this is as a whole the ductile cast iron part, and we have also a malleable cast iron section in the later half. You can see that malleable cast iron section, but I will come to that later on. And let me take you to the first position again, where you can see the pictures of two microstructures. I am repeating because this is very much important. And here you can see the gray iron or gray cast iron. Actually, I am again repeating, the gray iron is actually gray cast iron, and ductile iron is spheroidal graphite cast iron or nodular cast iron or ductile cast iron. So here you can see the graphite flakes. Upon an external force, the graphite flakes, they tend to actually break away through these lines, through these flakes lines. So that is why it is so brittle. And it is not brittle because these graphite nodules, they actually take up the force, take up the pressure, and binds the iron together. So as much force as it takes, it actually binds the total structure, total microstructure. So this is all for the ductile iron part. I will again make a video on the malleable cast iron, and I will again, actually, our main motto will be to compare these two. So the ductile cast iron, here I am actually stopping my lecture, and I know these are tough times, and but I believe that it will be over. It will be over soon. So stay well, and stay indoors, and stay fit, and with it, try to continue the study as far as possible. Study well. Thank you very much.